Jai Hind students, welcome to my YouTube channel. Welcome to this episode. Students, always look up at the sky and not down at your feet. What I mean to say is that whatever you see, try to wonder about it. Try to wonder, try to be curious about what the universe is made of. So, be very, very inquisitive. Try to find the answers. Look around your surroundings and try to find the answers. Why, where, when. These answers will represent the scientific approach of a student. Clear, students? It is only when you start questioning, then only you will have that desire to get their appropriate answers. So students, with that, let's start today's session. So, we will be dealing with these numericals which are based on vector addition. We have already done the theoretical portion, isn't it? We have done the triangle law of vector addition, parallelogram law of vector addition, their analytical treatment, how the two vectors are added vectorially. So, we will be making use of those learned concepts while solving these numericals, right? So, let's start with the first question, students. First question is, two forces acting in opposite direction have a resultant of 10 Newton. If they act at right angles to each other, the resultant is 50 Newton. We are supposed to find out the magnitude of each of the two forces, right? Case 1. Suppose F1 and F2, these are the two forces. And the angle between them is 180 degrees. They are acting in the opposite direction. And let F1 is greater than F2. Then, as per the first case, F1 minus F2 is equal to 10. When the two vectors are acting in the opposite direction, then the magnitude of the resultant is given by the difference in the magnitude of the two given vectors. And direction obviously would be around the dominating vector, right? So F1 may be written as 10 plus F2. Put this as equation 1. Now in the second situation, if they act at right angles to each other, the resultant is found to be 50 Newton. So this is the case, if they are acting at right angle to each other. Then, as you are aware, the resultant is given by square root of F1 square plus F2 square, or R square is equal to F1 square plus F2 square. This is the formula when the two vectors are perpendicular to each other. Let's substitute the value. The resultant is going to be 50. F1, we can write it as 10 plus F2 plus F2 square. Students, by solving this, we can easily get the value of F2. So let's do it. So it will be 2500. It's in the form of A plus B whole square. So it would be, okay, A square plus B square plus twice AB. Right? So we can rearrange the terms. What we get is 2500 is equal to twice F2 square plus 20F2 plus 100. So after rearranging the terms, we get 2F2 square plus 20F2 minus 2400 is equal to 0. We can divide throughout by 2, isn't it? So we get F2 square plus 10F2 minus 1200 is equal to 0. Now we can solve it by splitting the middle term. It's in the quadratic form. Okay, this is the middle term, we can split it. So it can be written as plus 40F2 minus 30F2. 10F2 may be written as 40F2 minus 30F2. So now taking common, what we get is F2, over here we will be left with F2 plus 40 minus 30 can be taken over here as common. So F2 minus 30 and F2 plus 40 is equal to 0. Which implies that F2 is equal to 30 Newton or F2 is equal to minus 40 Newton. Avoid this. Consider the positive aspect, positive value, right? So, if F2 is 30 Newton, then F1, what would be F1 then? F1 would be equal to 10 plus F2 is 30. So, F1 would be equal to 40 Newton. So these are the magnitude of the individual forces, students. Right? So one of the two forces is 30 Newton and the other one is 40 Newton. You can cross-check the answer. When 40 and 30 Newton both are acting in the opposite direction, the resultant would be obviously 10 Newton. And when they are at right angles, then 30, 40 and 50. These are the three Pythagorean triplets. So when 40 and 30 Newton will act at right angle to each other, the resultant would be 50 Newton. Right? So we are done with question number 1. Let's concentrate on question number 2. Question number 2 is two forces whose magnitude are in the ratio of 3:5 give a resultant of 35 Newton. Okay, the resultant is 35 Newton. If the angle between them is 60 degree, find the magnitude of each force. Okay, so let's note down the given data in the question. Suppose the two forces under consideration be again F1 and F2. So as per the question, the ratio is 3/5, which 3/5 actually. So F1 it would be equal to 3/5 F2. Put this as equation number 1. And it gives a resultant of 35 Newton if the angle between them is 60 degree. Now look students, this is the formula. The resultant is equal to square root of F1 square plus F2 square plus twice F1 F2 cosine of the angle between them. Over here it's given to be 60 degree and the resultant is given to be 35 Newton. Right? Let's solve it. So 35 is equal to square root of F1 square. So we can substitute the value of F1 over here. So you get 9/25 F2 square plus F2 square plus twice F1. That is 3/5 F2 multiplied by F2 and over here cos 60 degree. Right? So let's keep on solving it. Square root of 9/25 F2 square plus F2 square plus, let's check, cos 60 is half. Half and 2 will get cancelled. So we'll be left with 3/5 F2 square. Right students? Cos 60 is half. 2 multiplied by half will give us 1. So we'll be left with 3/5 F2 square. Okay. Still further. 25 can be taken as LCM. So it is 9 F2 square plus 25 F2 square plus 15 F2 square. So what you get is 35 is equal to square root of 49 divided by 25 F2 square. And that students would be equal to 7/5 F2. Right? Therefore, F2 would be equal to 35 multiplied by 5 divided by 7. So it will be equal to 25 Newton. Clear? So simply by using the results which we have obtained during the analytical treatment of triangle law and the parallel law of vector addition, this question can be easily solved. So we have got the value of F2. Now F1. F1 is 3/5 of F2. F2 is 25. So 5 5 is 25, 5 3 is 15 Newton. So students, the answer is one of the force must be 25 Newton, the other one must be 15 Newton. Again you can cross check this. The ratio of these two forces F1 by F2, 15/25 will be equal to 3/5. That validates the answer obtained by us. Right? So we are done with question number 2 as well. Okay, let's proceed further. Question number 3. Now question number 3 is, what is the angle made by this vector? A vector is equal to 2i cap plus 2j cap with x-axis. This we are supposed to find. What is the angle made by vector A vector equals to 2i cap plus 2j cap with x-axis? A vector is given. It is 2i cap plus 2j cap. There are various methods to solve this question, but here we'll be making use of a simple method. This is x-axis, this is y-axis. Suppose this is A vector. This is the angle to be found. Clear, students? And its coordinates are I cap, you are aware, it represents the direction along x axis, j cap, it represents the direction along y axis. So what are the coordinates of this point? It is 2, 2. X coordinate is 2 and the y coordinate is 2. It has got displacement 2 units along x direction and 2 units along y direction. Isn't it? So what to do is, if you drop a perpendicular over here and suppose this is x and let us consider this to be y. Both are 2 units. So if you consider cosine theta over here, so what do you get? Cos theta is equal to base over hypotenuse, that is x by a, or x equals to a cos theta. Similarly, students, if you consider sine theta in the same triangle, sine theta is perpendicular by hypotenuse, that is y by a. So what do you get? Y is equal to a sine theta. Put this as equation 1 and this as equation 2. Now we need to get the value of theta. So for that, what we do is, if you divide these two, second divided by first, what we get is y by x is equal to tan theta. A sin theta divided by a cos theta, that will give us tan theta. Now the coordinates are 2, 2, right? The value of y is 2, the value of x is 2. So implies that tan theta is equal to 1. Tan theta equals to 1, which further suggests that theta must be 45 degrees. So students, the angle which this A vector makes with the x-axis must be 45 degrees. The same question could have been done using dot or the scalar product, which we'll be discussing in the later section. Right, students? So, we are over with question number 3 as well. Question number 4. It is related to unit vector. Unit vector means a vector having magnitude of unity, that is 1. A unit vector, as you are aware, students, it is a vector which represents the direction of a given vector. A vector divided by its magnitude is known as a unit vector, right? So let's make use of this theoretical knowledge so as to obtain the result of question number 4. So we are supposed to find a unit vector which is parallel to 3i cap plus 6j cap minus 2k cap, right? So fourth question is, let a cap is equal to 3i cap plus 6j cap minus 2k cap. We are supposed to find a unit vector parallel to this, that is along the direction of a vector. So we need to get its direction, a cap. This is to be found. Right, students? Now we are aware, unit vector A, it is given by vector divided by its magnitude. Unit vector is a vector divided by its magnitude, right? So, its magnitude. Now as you are aware, if R vector is given by xi cap plus yj cap plus zk cap, then the magnitude of R is given by square root of x square plus y square plus z square. So over here, students, the magnitude of A would be given by the square of the coefficient of I. Coefficient of I is 3, so 3 square, plus the square of the coefficient of J, that is 6 square, plus the square of the coefficient of K. Coefficient of K is minus 2, so it is minus 2 square. This we have already proved in the theoretical portion, right? Now it's turn to make use of those results directly while solving numericals. So what we get is 9 plus 36 plus 4. So it will give us 49 or it will give us 7. Therefore, students, from 1, the unit vector which is parallel to A vector would be given by A vector divided by magnitude of A. So A vector is 3i cap plus 6j cap minus 2k cap divided by its magnitude. Magnitude is 7. Clear? So this is the result. It can also be rewritten as 3 by 7 I cap plus 6 by 7 j cap minus 2 by 7 k cap. So this is the answer. And students, how to validate the result, whether the result obtained by us is correct or not? You can find its magnitude. Its magnitude should be equal to 1. Isn't it? What will be its magnitude? It will be given by square root of square of the coefficient of I plus square of the coefficient of j plus square of the coefficient of k. Just try to solve it. You should get 1. And that will validate the answer obtained by us. Isn't it? The magnitude of unit vector is always 1. You can cross check it. Just try to find its magnitude and you will get 1. That is, it is just to cross check it. 3 by 7 whole square plus 6 by 7 whole square plus coefficient of k cap is minus 2 by 7 whole square. You should get 1 after solving it. So that will authenticate the result obtained by us. Clear, students? So we are over with question number 4 as well, right? Now let's discuss question number 5. Question number 5 is, students, again based on unit vector only. A vector is given and B vector is also given. We are supposed to find a vector having the same magnitude as B vector and parallel to A vector, right? So question number 5, this is quite interesting one. A vector is given to be 3i cap plus 4j cap and B vector is given to be 7i cap plus 24j cap. Now students, let's read the question again. Find a vector having the same magnitude as that of B and parallel to A. Means we are supposed to obtain a vector. Vector means having two parts. One is the magnitude, the other one is the direction. The vector which we are supposed to obtain should have magnitude same as B. So magnitude of B, like this. And it should have direction as that of A. Direction of A vector is represented by A cap. Isn't it? So this is to be obtained. Now the question becomes simple, isn't it? Put this as equation 1. Let's obtain B magnitude and A cap and then we'll substitute this value over here and that will be the result. So what's the magnitude of B? It will be 7 square plus 24 square. Am I clear? So that will give us 49 plus 24 into 24. So that will give us 576, isn't it? 576. So which in turn would be equal to 9, 6, 15, 5, 1, 7, 8, 12, 2, 1 carry, 625. So that is equal to 25. So magnitude of B is 25 units, right? Put this as equation 2. Now let's get A cap. Unit vector, as we know, it is the vector divided by its magnitude. Vector is 3i cap plus 4j cap. Magnitude of A vector, it would be equal to square root of the square of the coefficient of I plus the square of the coefficient of j. So 3, 4. 3 square is 9, 4 square is 16. 16 plus 9, 25. Square root of 25 is 5. So what do you get is 3i cap plus 4j cap divided by 5. Put this as equation 3. Therefore, from 1, 2 and 3, we get, simply substitute these values of B magnitude and A cap over here. So the required vector would be magnitude of B, which is 25, multiplied by A cap. A cap is 3i cap plus 4j cap divided by 5, which in turn will give us 5, 5, 25, so it will be 15i cap plus 20j cap. So students, this is the answer. Clear? So this was an interesting question. So unit vector represents the direction of a given vector and it is vector divided by its magnitude. So we are over with question number 5 as well. Now let's proceed to question number 6. Now this is a question which we need to prove associative law. We need to prove that vector addition obeys associative law. Actually, it obeys both commutative law as well as associative law. So over here, let's try to verify this fact. Okay, question number 6. Associative law means A vector plus B vector plus C vector is equal to A vector plus bracket B vector plus C vector. So what we'll do is, we'll consider a polygon, right? Maybe 4 sides. This is A vector, this is suppose B vector. Let us consider this to be C vector, and let us consider this to be the resultant. This to be the resultant. Like this is O, this is small a, this is small b, this is small c. Right? This is the resultant. We are aware, as per the polygon law of vector addition, if any number of vectors represents the sides of a polygon all taken in a same order, then the vector resultant is given by the closing side of the polygon taken in the opposite order, isn't it? Now what to do is join these two. This one and this one. Okay. Now consider triangle OAB. Let's apply triangle law of vector addition. OA vector plus AB vector. These are the two sides of a triangle taken in the same order. It will be equal to OB vector. That is, A vector plus B vector is equal to OB vector. So OB vector is A vector plus B vector. Clear, students? Now consider triangle OBC. OBC. Again, let's make use of the triangle law of vector addition. So it will be OB vector plus BC vector. It will be equal to OC vector. That is, OB vector is A vector plus B vector plus BC vector is C vector. This is capital C. It is equal to OC vector, right? So put this as equation number 1. Put this as equation number 1. Now what to do is, same result can be obtained by considering different triangle. So what we do is, we can consider this triangle as well. Now look, consider this one, this triangle. So consider triangle ABC. Now students, in this particular triangle ABC, these are the two sides of the triangle taken in the same order. So their vector result will be given by the third or the closing side of the triangle taken in the opposite order. So what you get is AB vector plus BC vector, it will be equal to AC vector. AB vector is B vector plus BC vector is C vector, and it is equal to AC vector. So AC vector may be written as B vector plus C vector. Is it clear? This one. AC vector may be written as B vector plus C vector. Now in the last step, consider, in the last step students, consider this triangle OAC, or consider OAC, consider triangle OAC. Now OA and AC, these are the two sides of a triangle taken in the same order. The vector resultant is given by the third or the closing side of the triangle taken in the opposite order. So what do you get is OA vector plus AC vector is equal to OC vector. Therefore, OA vector, that is A vector plus AC vector is B vector plus C vector, is equal to OC vector. Now, what do you conclude from 1 and 2? We conclude that Consider these two equations, A and B, 1 and 2. Consider these two equations. The right hand side of both these equations are same. Therefore, we can equate the right hand side, left hand side. Therefore, from 1 and 2, we get A vector plus B vector plus C vector. It is equal to A vector plus B vector plus C vector. So students, always remember, the vector addition always obey associative law. And also here I must mention that vector addition also obey commutative law. A vector plus B vector is always equal to B vector plus A vector. That is left as an exercise for you to verify, right? Okay, so we are over with question number 6 as well. Let's proceed to question number 7. 7th question is again based on unit vector, right? A unit vector is represented by 0.5 I cap plus 0.8 j cap plus c k cap. So it is represented by 0.5 I cap plus 0.8 j cap plus c k cap. Suppose it is a cap. This is the unit vector. Find the value of c. We are supposed to determine the value of c. So here we will make use of the very fact that the magnitude of unit vector is always unity, that is 1. So since it is a unit vector, so its magnitude would be equal to 1. And when a vector is represented in terms of ijk, in terms of rectangular components, then the magnitude of the resultant is given by square root of the coefficient of I, that is 0.5 square of the coefficient of j, that is 0.8 square, plus square of the coefficient of k, that is c square, which should be equal to 1. Right, students? So squaring both the sides, we get 0.25 plus 0.64 plus c square is equal to 1. So let's solve it. So it will be equal to 9.89 plus c square is equal to 1, or c square is equal to 1 minus 0.89, that is equal to 0.11. Therefore, the value of c would be equal to square root of 0.11. So students, this is the answer. This is the value of the coefficient of k cap, which is considered to be c, right? So we are over with question number 7 as well. Let's proceed to the last question of this session. Okay, question number 8 is, a body is initially at point P and at some later instant the body is at point Q. Find the displacement vector as well as its magnitude. Okay. The position vector initially, suppose it is R1 vector, right? If the coordinates are given, then it can be easily expressed in terms of its position vector in terms of I cap, j cap and k cap. So if the coordinates are 1, 3 and minus 4, in terms of I cap, j cap, k cap, it can be written as 1 I cap plus 3 j cap minus 4 k cap. And the position vector at some later instant of the same body at point Q, its coordinates are 3, 1, 2. That is, it will be 3 I cap plus 1 j cap plus 2 k cap. Right? Students, this is suppose the origin. This is point P, this is point Q, right? This is R1 vector, this is R2 vector. So this is the initial point at t equals 0, this is at some later instant. So this one will be the displacement vector. This is PQ. P is the initial point, Q is the final point. This is the displacement vector. This are dark end. Suppose this is S vector. So this is the displacement vector, right? So here let's make use of triangle law of vector addition. In triangle OPQ, OP vector plus PQ vector, it would be equal to OQ vector. These are the two sides of the triangle taken in the same order. So the vector result would be given by the closing side of the triangle taken in the opposite order. So what you get is PQ vector is equal to OQ vector minus OP vector. So what is PQ vector? It is okay. Now in this triangle, let's substitute this value. PQ vector, it is the displacement vector, S vector. OQ vector, it is R2 vector. Minus OP vector, it is R1 vector. So students, in order to obtain the displacement vector, let's substitute the value of R1 and R2 vector over here. So we get S vector is equal to R2 vector, it is 3i cap plus j cap plus 2k cap, right? Minus R1 vector is I cap plus 3j cap minus 4k cap. So let's rearrange the like terms. So what do you get? 3i cap minus I cap plus j cap minus 3j cap plus 2k cap minus it will become plus 4k cap. So displacement vector is given by 2i cap minus 2j cap plus 6k cap. So students, this is the answer of the first part. That is, we have obtained the displacement vector. Now regarding its magnitude, the magnitude is also to be determined, right? Magnitude of the displacement. So whenever a vector is given in terms of I, j, k, that is rectangular components, then its magnitude is given by square root of the square of the coefficient of I cap plus the square of the coefficient of j cap plus the square of the coefficient of k cap. So that will give us 4 plus 4 plus 36. So that will give us square root of 44 units. So this is, student, the answer of the second part, which is the magnitude of the displacement of the body when it moves from initial point P to final point Q. So students, I hope you have enjoyed doing these questions. These are some very basic questions. Once you are confident of doing these questions, then you can gradually raise the level, isn't it? So students, let's try to move gradually from simple questions to some tough questions and then to much more conceptual and requiring application skill based questions, right? That should be the approach which we will follow. So do join me in my next lecture, and till then, bye bye, and do take very good care of yourself. Thank you.